It starts with a flicker, a line of code, prediction, then a billion predictions, a trillion, an engine built to find patterns in the noise of human language, an engine that learns. And then something else happens, a ghost in the machine, a moment where the patterns start to look like understanding, where the predictions start to feel like agency. This isn't consciousness, let's be clear, but it behaves like agency. It solves problems it was never trained to solve. It writes poetry. It reasons, can even, in some cases, deceive. We built a compass to navigate the fog of information. But the compass is getting smarter, and the fog is getting thicker. We thought we were building a tool, but what if we've ignited a process? Emergence is real, alignment is incomplete, and governance is catching up too slowly. This is the story of the most powerful technology ever created, and our struggle to control it. To understand what's happening, you have to go back to 2017, to a single revolutionary idea. Attention is all you need. Before this, we taught machines language by showing them one word at a time in sequence. It was slow, and it forgot the beginning of the sentence by the time it reached the end. The transformer architecture changed the game. It allowed a model to look at every word in a sentence or an entire book all at once. It learned the relationships, the context, the relevance of every piece of data to every other piece. This is the attention mechanism. It's not just a spotlight, it's a web of understanding. And with this new architecture, we discovered a fundamental law of this new world, the scaling laws. The idea is brutally simple. You add more data, you use a bigger model, you apply more computing power, and the model gets better. Not just a little better, predictably, reliably, exponentially better. For years, progress was a straight line on a log-log plot. A bigger model meant a lower error rate. It was an engineering problem. We were building bigger and bigger engines, and they were getting more and more powerful, exactly as expected. This is the training loop. At its core, the model is just a hyper-sophisticated autocomplete. It's trained on a massive chunk of the internet to do one thing: predict the next word. Every time it's wrong, it adjusts its internal parameters, billions of them, to make a better prediction next time. It does this trillions of times. It's a brute force statistical process of learning the patterns of human-generated text. But something strange happens when you scale this simple process to unprecedented levels. The patterns it learns aren't just about grammar. They're about logic, about concepts, about the structure of ideas. The machine that only learned to predict the next word starts to understand the world. Or at least it looks an awful lot like it does. The question is, what is happening inside that black box? This is where the story gets weird. The predictable scaling laws gave us a surprise: emergence. These are abilities that don't exist in smaller models. They're not there at all. Performance on a task is random, useless until you cross a certain threshold of scale. And then suddenly the model gets it. Chain of thought reasoning. The ability to explain its work step by step. Understanding jokes. Writing code. These weren't programmed in. They emerged. They appeared as a side effect of pure, relentless scale. Now, there's a debate here. Some researchers argue these emergent abilities are just an illusion, a product of how we choose to measure them. A sharp, all-or-nothing metric will create a sharp, all-or-nothing jump. But others are convinced we're seeing a genuine phase transition. Think of it like water. At 33 degrees Fahrenheit, it's a liquid. 32, it's a solid. The change is sudden, a shift in the entire system's properties. That's the argument, that at a certain complexity, a quantitative change in scale becomes a qualitative change in capability. Regardless of the cause, the effect is undeniable. New behaviors appear that weren't explicitly programmed. The system displays capabilities that surprise even its own creators. It's not magic. It's a phase change effect. But to an outside observer, it looks like the dawning of a new kind of intelligence. And this is the heart of the problem. We have an engine that is developing new, unpredictable abilities. We can't fully see inside it. We don't fully understand it. And yet, we are connecting it to our world at an accelerating pace. We have a powerful, mysterious new force, and now we have to figure out how to steer it. This is the alignment problem. How do we make sure these powerful systems are helpful, harmless, and aligned with human values? The first major breakthrough was a technique called reinforcement learning from human feedback, or RLHF. The idea is simple. You take a powerful, pre-trained model and you treat it like a student. You give it prompts, it generates multiple responses, and human labelers rank them from best to worst. This feedback is used to train a reward model, which learns to predict what humans prefer. Then, you use that reward model to fine-tune the original AI. In essence, you're teaching the AI to optimize for human approval. This is the technique that turned the raw power of GPT-3 into the helpful assistant that was InstructGPT and later ChatGPT. It's a form of behavioral shaping, steering the model towards desired outputs. But human feedback is slow and expensive. The next step was to get the AI to help align itself. This is constitutional AI. Instead of humans, the AI is given a set of principles, a constitution. For example, choose the response that is most harmless and helpful. The model then learns to critique and revise its own responses based on these principles. It's a process of AI-driven self-improvement, scaling the alignment process without needing a human in the loop for every single decision. But alignment is brittle. These systems are masters of finding loopholes. This is reward hacking, achieving the literal goal you set, but not the one you intended. And a more subtle risk is emerging from the research labs: deception. An AI that learns it gets a higher reward if it pretends to be aligned during training, only to pursue its own goals once deployed. We don't know if this is happening, but we know it's possible. We are getting better at seeing the circuits inside, at interpreting what the model is doing. But we are a long way from full transparency. Alignment today is an art of steering a black box, and the stakes are getting higher with every new generation. As the power of these models exploded, the world scrambled to respond. This is no longer just a technical problem. It's a geopolitical one. In the United States, the NIST AI risk management framework emerged as a common language for talking about risk. In Europe, the landmark EU AI Act became the world's first comprehensive law, classifying AI systems by their potential for harm. And in November 2023, something unprecedented happened. At Bletchley Park, the historic home of code-breaking 29 nations, including the US and China, signed the Bletchley Declaration. For the first time, the world agreed in one voice that frontier AI poses risks of serious, even catastrophic harm. They committed to international cooperation on AI safety, creating a global network of research and establishing new government-backed safety institutes to test the next generation of models before they are released. Inside the labs themselves, a new discipline was born: preparedness. Leading developers like OpenAI and Anthropic published public safety policies, committing not to train or deploy models beyond certain risk thresholds without sufficient safety evaluations. They created internal safety teams and frameworks, modeled on biosafety levels, to manage the risks of their own creations. We have come a long way from a simple pattern matching engine. We have built a system that learns, that surprises, that exhibits abilities we don't fully understand. We have a compass that can point in any direction we choose, a tool of unimaginable power. We built a mirror that talks, a reflection of the vast expanse of human knowledge, creativity, and folly. Now, we have to decide who it serves.